guy. Okay, so my name's Ike Ellis. I'm a data platform MVP, and I've written a book called Developing Azure Solutions for Microsoft Press that I'm revising for the second edition right now. It should be out late summer. And today we're going to talk a little bit about Azure Data Lake. First, we need to make a couple of vocabulary changes here. A data lake is a generic software and data architecture term. And data lakes have been implemented using a wide variety of technologies. But typically, data lakes are built in Hadoop. I would say the vast majority of data lakes are built in Hadoop. But they could be built in several different, they could be built in Amazon S3, they could be built in Azure Blob Storage. There's a lot of different technologies that can be used in conjunction to build a data lake. So this product that we're going to talk about is an Azure product called Data Lake, not to be confused with the generic data architecture term. So real quick, what's the term mean? A data lake is a single store of all data ranging from raw data like CSVs or log files or even PDFs to transform data, which is used for various forms including reporting, visualization, analytics, machine learning, and I would include also cleaning and data preparation. Those things could all happen inside of a data lake. And it could be relational data in the data lake, but it could also be just like you dumped a bunch of sensor data coming off of an IoT application in the data lake. James Dixon, the CTO of Pentaho, is actually the person who first coined the term. And he said, if you think of a data mart as a store of bottled water, cleansed, packaged, and structured for easy consumption, the data lake is a large body of water in a more natural state. And that really holds up because if you think of a data lake, what we're trying to avoid doing is moving the data. So once we have the data, we just store it in one place and we try to avoid moving it again because moving is expensive. If you look at like the big four hardware resources that we worry about CPU, memory, disk I/O, and network I/O. The slowest and the most difficult to upgrade is network I/O. And so the idea of a data lake is rather than piping data from this database to this database to this database all over the place and consuming a bunch of network I/O, we will avoid that by just keeping data where it sits and then cleaning it where it sits and using it where it sits, particularly if there's a lot of it. In addition, anybody who's done any data mart building knows that about 70% of the time of building a data mart is used in ETL processes, building, extract, transform, and load processes like SSIS. And that's a lot of time. In order to clean it, you're building these packages and then you're debugging them. They're hard to debug. They're somewhat slow. Getting it to do the deltas can be difficult. Getting a proper framework in place can be difficult. So the idea is once you've got it in place, clean it there and don't worry so much about piping it. And if we ever need to change it, we can just change it where it sits. Okay. So if we look at the different big data offerings on Azure, we can go like on-premise, we know we can build big data work in using Azure API, or excuse me, using Microsoft APS or using Microsoft SQL Server. And then if we move over to infrastructure, we can create infrastructure as a service. We can create Azure virtual machines. By the way, Jason, can you see my slides okay? I hope so.
Yep, everything's coming through.
Okay, great. Okay, great. So you could build VMs in Azure and you could install any Hadoop distribution that you want. You could install Cloudera or MapR or Hortonworks, and you can, you're administering the operating system, that's usually Linux, but it can be Windows. You're administering the application and virus checking and updating and upgrading and all that stuff. Or you can move over to a platform as a service offering like HDInsight. HDInsight is Azure's implementation of Hadoop as a platform as a service, and it uses the distribution from Hortonworks specifically. And what that means is that Microsoft is maintaining the operating system and the hardware for you. and you're just using the different HDInsight products that are available to you, including Apache Storm, Pig, Hive, Squoop, all the things that HDInsight offers, right? And if you move over a little bit farther to software as a service, this is where Azure Data Lake, the product, sits. And what that means is Microsoft hides the implementation of the cluster from you so that you don't really know how many nodes are running on Azure Data Lake. You don't really know what the implementation details are. You don't even know the distribution of Hadoop you might be using if you're even using a distribution of Hadoop. So what that allows you to do is just focus on writing code in Azure Data Lake to, do batch analytics, to do ETL processing, to ingress IoT data. All that stuff is done as you write scripts, and you're not really hyper concerned with like how many nodes in the cluster you need to build, or are you spending too much money, things like that. You know what, because my slides are a little bit wanting, I think I want to move over to MS Paint for a second. So what I want to talk about a little bit is the whole idea behind MPP. So let's just do a little bit of Paint together, because I don't have a whiteboard. If I had a whiteboard, I would be sitting there with a marker in front of the class, and you guys would think, oh, this is so nice, we can just be interactive. So if you have a bunch of nodes, like that you're creating here, all these nodes, right? And you have a really long script that we're writing, right? So this is my script. Let's see, I want more of a free-form brush. How about this? These are lines of code that I'm making here, right? And if I wanted to divide this script up to be ran on multiple computers, right? What I would have to do is I'd have to create a dividing line here. I'd have to say, okay, this is part 1 of the script, this is part 2 of the script, and this is part 3 of the script. And then I would say, okay, part 1, let's get rid of that. Part 1 runs on this machine. Part 2 runs on this machine. Part 3 runs on this machine, right? So if I do that, and each one of those nodes is running its specific portion of the script, there could be problems along the way, right? A lot of problems. Like I could have like poor performance. This node might be poor performing. This node might go down. This node might be, this node might be fine, totally fine. So if one node is poor performing, I need to build into my script the logic to detect which node is poor performing. And if one node goes down, I need to build into my script the logic of retrying, like, hey, let's make sure we can put that on a node that goes up again, right? Or if one node is fine, I need verification that that node did its job well and that everything came back. In addition, when all of these nodes finish processing, I need to kind of collect all of that stuff into one place that's easy for me to manage. So that has the net result of making this script over here bigger and bigger and bigger and bigger. So I'm building all this logic that's not really necessary for my application in order to take advantage of the fact that I want one thing to run on multiple computers, right? That problem is a well thought through problem that deals with massive parallel processing. So if you understand that what Hadoop at its core is a framework that takes the job retries and security and logging and all the things that go into dealing with making one workload go across multiple nodes. And it just builds it into a reusable framework so that you don't have to write that into your script each time. So Hadoop at its core is just a reusable framework with all the things that deal with MPP in one place so that you can focus on writing business logic. Now, that sounds pretty great. Why do we need Azure Data Lake? Well, let's come back to the slides. Does that make sense? Hope that made sense. So the problem with Hadoop that most Hadoop administrators have is that you have to pick how many nodes you're going to use when you install it. So if you look at your data workload and say, you know what, I need 4, and you build 4 nodes, and it turns out you were wrong and you need a fifth node. So you add the fifth node, you have to move the data around to the fifth node, and that could take some time. I don't know how much time. Maybe it takes a half hour, maybe 3 days. But moving the data around because you guessed the nodes wrong is time consuming. And if you need to add 8 nodes or 12 nodes, now you're partitioning the data up and moving it around even more, and that's time consuming. Now that you have 8 nodes, it might be difficult to patch all those nodes. It might be difficult to keep them all in the same version. It might be difficult to virus protect them. They all have to be powered and cooled, and all that stuff goes into it. Or let's do the opposite thing. The opposite thing is, what happens if I look at my workload and I think, oh, this is 32 nodes. So you go and get all the hardware, the Azure VMs, you build your nodes, you distribute the data, and you're like, oh my gosh, this is way too many. I spent way too much money and I spent way too much time. And so you want to move down. It can be somewhat difficult to move down or time consuming. And it doesn't matter if it's 20 minutes to move down or 3 days to move down. There is some amount of pain when you guess the number of nodes that you need incorrectly. So what Azure Data Lake does is it's clusterless, which means you don't have insight into how many nodes are behind the scenes available to you. But what you can do is when you create a job, you can slide what they call it an AU or analytic unit. You can slide your analytic unit up and down and dictate how many nodes you use for that individual job. And that is only for that execution of the job. So if I build an amazing job in Azure Data Lake Analytics, and I'll talk about that in a second, and I use 20 nodes when I run, and I think, oh, that's way too many. The next time I run the same script, I can drop it down to 10 without having to reprovision or think about it. I only pay for how many nodes that job uses at the time of execution. And that's the advantage of a clusterless environment. So I've introduced some of the reasons why Azure Data Lake was built. I talked to you about maybe some of the drawbacks that Hadoop has traditionally have had and why ADL is so important in the market today. And really, by the way, not to sound grandiose, but there's really no other product like Azure Data Lake on the market. There are some that try to be it, but ADL is a very, very unique product, and it's a highly needed product, one that has engaged a lot of people and built a lot of interest recently. So I'll talk about this in just a second, but Azure Data Lake really has a great ability to leverage your existing skills. Specifically, if you're a SQL and C# developer, you'll find the move over to Azure Data Lake to be not effortless, but definitely a lot less painful than moving to Hadoop. So what has happened with Microsoft developers, Hadoop has traditionally been Java developers. And recently, we've got a lot, and when I mean recently, I mean the last 2 or 3 years, we've gotten a lot of Python and Scala developers in Hadoop. But C# developers haven't really been welcome in that community. There have been some attempts, but not really. So what Azure Data Lake does is it really opens up the power of MPP to a group of developers, and there are a lot of them, that have MPP problems, but haven't felt typically welcomed in the MPP community. So keep that in mind, in the back of your mind as we talk about this. It's elastic. You can dynamically provision compute based on the specific query. You have infinite storage capacity, which sounds like a grandiose statement, but really you can store a ton of data in Azure Data Lake without hitting a top end. And then you can extract meaning from your data and not worry about the infrastructure. So Azure Data Lake is actually 2 separate products. The one product is called Azure Data Lake Analytics, or ADLA, and the second product is Azure Data Lake Store, or ADLS. So if you look at my slide, the store is at the bottom, and we're going to focus on the store first. But what Azure Data Lake Store, ADLS, is it's just a parking spot for all of your data, for CSVs and for whatever data you want to store in there, you can store. It's very similar to Azure Blob Storage, although there are some key differences, and we'll explain that in just a second. You don't really know how Azure Data Lake Store is implemented, but it behaves as if it is HDFS. HDFS stands for Hadoop Distributed File System. So if we go back to my little paint diagram here, and I said, hey, look, this is a script. Let's pretend this isn't a script. Let's pretend this is a very large file. And let's say that this file is 500 terabytes. And I look at this file, and I don't want to store this file, 500 tera, on one computer. Because if I do that, and that computer goes down, I lose access to everything to do with that file. In addition, if I traverse that file on one computer, it can take a long time for me to find the data that I care about. So instead, I take this one file and I put a little bit of file on node 1, a little bit of the file on node 2, a little bit of the file on node 3. What that requires of me, if I do that, is I have to have a different node kind of in front of it. And that node that's in front of it is what's called the name node. So if I put this like here, I know this is a terrible diagram now, but I'm kind of cluttering it, but you guys get the idea. This is a name node. And what that name node does is it kind of works like any file system, like NTFS or a FAT file system. What it does is it says, I know you're storing one file on multiple machines, and I'm going to record what portion of that file is on each node. And I might make duplicates of that portion into other nodes so that if one node goes down, I can get access to that file in a different node. And it works like a directory entry table. So it's just a pointer to where that file is physically stored so that when, as a user, you say, hey, I want that file back, the name node knows where to get the portion of the file you care about and bring it back to you quickly, right? So the reason why I tell you that as we talk about Azure Data Lake Store is Azure Data Lake Store isn't implemented across multiple nodes the same way HDFS is, but it exposes the same HDFS API so that Hadoop doesn't know that. Any of the Hadoop products won't know that. And so what that means is we could store a bunch of data in Azure Data Lake Store, and we can use Azure Data Lake Analytics over top of it, but we don't have to. We absolutely do not have to. And if you look at this diagram over here, you'll see clusters like HDInsight. We might implement Spark or Pig or Hive or other Hadoop products that are open source and available to us and use Azure Data Lake Store, which is where our data is, and never use Azure Data Lake Analytics at all if we don't want to. Like if we're a bunch of Spark developers and we really know Scala really well or Python, then we could implement that in HDInsight and still use the same data in Azure Data Lake Store all day. And it's relatively affordable. It's as Hadoop implementations go, it's really cheap. So here are some advantages we have with Azure Data Lake, by the way. This is kind of more of a marketing slide from Microsoft, but we can import data into it. We can query ADL using federated queries. We can pull data out of it using Power BI, although I think there's a better use case. I wouldn't directly use Power BI over ADL. I'd probably use it to seed like an Azure Platform as a Service analysis services cube, like a tabular cube, because you'll get a more interactive and interesting experience if you do that. And then you could use batch processing for data discovery and things like that. So like I said, Azure Data Lake Store is HDFS as a service. It's durable. It's high capacity, high frequency, high throughput, very fast, and you can store data in its native format. So if we're going to compare Azure Data Lake Store with Azure Blob Storage, what you'll see is ADLS is optimized for analytics. And really, if that's all you need to know, that's all you should know, is that ADLS performs very, very well with larger files and batch processing, where Azure Blob Storage, which I don't know if any of you went to my session last time where we did a lap around the Azure Data Platform, and I talked about blob storage there. Azure Blob Storage is good for smaller files, very fast for smaller files, but maybe not for some of the larger ones. They both have web HDFS. Azure Blob Storage just recently introduced that, which is awesome. You pay for your data stored and for I/O, and you do not pay for compute, and that's important. You can query this data as much as you want, and you're only going to pay for the data traffic coming in and out of Azure. You're not going to really pay for any compute costs. You can also have billing tiers. Like if you say, oh, I know I'm going to use 50 tera in Azure Data Lake Store, you'll get a much cheaper price if you do that. Azure Blob Storage doesn't have anything like that. Okay. So like I said earlier, we could also use Azure HDInsight. This is Azure's Hadoop platform as a service offering with all the different Apache technologies like HBase and Storm and Spark. We could focus on query and data and not have to build our infrastructure, and we pay for, you know, the main difference with HDInsight is you pick your parallelism when you build your HDInsight offering. So what that means is if you build 4 nodes, you're going to pay for 4 nodes whether you're using them or not. Where in Azure Data Lake Analytics, you can, like I said earlier, you can choose how much you pay for with that sliding bar. So Azure Data Lake Analytics is free. You could install it right now for free as long as you don't use it. As soon as you use it, it's 3 cents per AU per minute, which means if you want to play with it right now, you can write 100 queries and, you know, pay a few dollars, right? You don't have to. With HDInsight, if you want to play around with that, I'll be honest, like you're probably going to, at minimum, spend $100 a month. And that's if you remember to dismantle it and you only, you know, you build it, play with it, get rid of it, you're still going to spend some money to do it. So HDInsight and Azure SQL Data Warehouse, I don't know if you've used that before, but Azure SQL Data Warehouse can be expensive. To just, every time I demo Azure SQL Data Warehouse, it costs me probably $75 to demo it. It's a lot of money. So, and if you're not careful with Azure SQL Data Warehouse, you could easily spend a couple $1,000s a month before you know it. So you've got to be very careful about pausing it when you're not using it. But Azure Data Analytics, you don't really have to be careful because you only pay when you're using it physically, and if the no job's running, you don't pay, which is great. And in order to use Azure Data Analytics, you write in an open source language that Microsoft has released called U-SQL. And what U-SQL is it's a combination of SQL, the language, which you guys should all know, and C#. And I'll show you that in just one second. So Azure Data Lake Analytics, so we switch topics, by the way, and I'm going to demo this right now after this slide. Azure Data Lake Analytics is very good at batch processing, which means you build out a script, you execute the script, you wait a certain amount of time, and it could be a minute or 5 minutes or 20 minutes or an hour, and then you get your results, and your results get piped someplace, and then you look at your results and you see if what you did was right. And that type of batch processing is ideal for very large amounts of data, but it makes it difficult to code, right? Because you've got to run it and see what you did wrong and then rewrite it. And it makes it difficult to have an interactive experience. Like if you did the math wrong, you can't just stop it at the point where the math was wrong. You have to rewrite it and then resubmit the whole job again. So that is a pain point, but it's a pain point with all batch processing. And it doesn't matter if you're writing ETL packages in SSIS or you're writing Hadoop MapReduce jobs. Everybody who's ever done batch processing has had that pain, right? And they know that. That's why Apache Storm is so popular, because Storm is a more interactive experience than typical MapReduce and Hadoop. So ADLA is bringing interactive query processing to the market in 2017. And I can't tell you when, because I don't know when. I mean, I've been hinted at when, but I think you can guess that, you know, maybe sooner rather than later. So pay attention because it's coming. And then machine learning over ADLA is coming, and then streaming analytics like Kafka, Hadoop Kafka, or Azure StreamInsight would be competing products to it. Those are on the roadmap and they're working on it. So just be aware, this is where it's headed. So even if you don't really like the product now, don't dismiss it permanently, just dismiss it temporarily and come back, because this product is changing at a rapid rate and it's getting used at a rapid rate, and a lot of people really like it. Okay, so let's demo this for a second. I'm going to open up this is my Azure Management Portal. And if I want to create a new data lake, I can just click New, and I can say Azure Data Lake. And you can see there's Data Lake Store and Data Lake Analytics. And once you I'm not going to create them now, although I could easily, but I don't want to take your time. But what you can see is that I already did create them. I have, if you go to my all resources, I have ADLA Ike, and I went to call it ADL Ike ADLS, but I called it ADLA Ike ADLS. So that ADLA Ike is my analytics account, and then ADLA Ike ADLS is my Data Lake Store account, right? And then once you build ADLA and once you build Azure Data Lake Store, you can explore the data. So I click on it and I click Data Explorer. You can see that there is a file system here. And I could create a new folder, right? I could just say test, and now there's a test folder here, right? Now I've already created a folder called baseball stats. And I've got a CSV that I've uploaded called baseball.csv. Now, just to kind of show you, what I did, if you care, is I went to baseball statistics. This is a great site, by the way, if you like baseball. I like baseball. I don't know if you guys do. So baseball-reference. What you could do is you could just click on anything, and it will show you, information about teams and about seasons and about Hall of Famers. And if you like something, you can click here and just say, please, get this as an Excel workbook. And so what I did was I grabbed an Excel workbook for last year, for 2016, every player in the majors and a few things about them. I just grabbed the games they played, their home runs, their batting average, and their on-base percentage. And you could see, like, how many players did I grab? I grabbed 1,600 players of data, right? You can also see that the header of this file is in the first record. So that's the rank, and their name, and their age, and their team, and the league they're in, and so on, right? So once I did that, I went to ADLS, and I just uploaded it. In fact, just to kind of prove it to you, I'm going to go ahead and delete this file. It's always dangerous, right? Because I have a demo that's working, and I'm going to make it not work. And I can click Upload, and I can go find that file again, and here it is again. And I can just say, hey, please overwrite it. And it tells me it uploaded it. And then I come back here, and if I just refresh here, there it is. And if I want to look at it, did that upload correctly, I can just click on it. And right here in the Azure Management Portal, it will show me that file. Okay, so you can see how easy it is to get data into Azure Data Lake Store. Can you see this okay, Jason?
It's a little bit small, but if I use the zoom on the GoToWebinar, it does come through quite a bit better.
Okay, good. Okay,
so if I set it as 50% zoom on GoToWebinar, it comes through a lot better.
Okay, so yeah, use the Zoom, guys. Sorry about that.
No problem. Real quick, there is a question that came through here that actually, that you might want just to think about as you're going through an answer. With a large amount of data that you may have in Data Lake, the demands for providing visualizations and analysis of the data exceeds the ability for the development team to handle, so users begin to want to use self-service BI tools like Power BI. How do you manage the access for all those diverse users with tools that can basically scrape through everything?
Well,
you'll probably
I
as you go through
about that. So first off, I'm gonna kick it back, right? And here's what I disagree with. I agree that users want self-service BI, but in my experience, putting users on data with no restriction, you're playing a very dangerous game because you're allowing them to come up with their own analytics. So even if there's a ton of data, it's still, if the demand is there to analyze it, then we need to consider that we should at least clean it. And that means that when they create metrics, they're creating metrics on data that IT has certified. So the problem I have with self-service analytics in general is that I don't think it exempts IT from doing its job. And IT's central job is, hey, this data is good, it's available, and it will always be available to you, and it will always be approved and good. So this is a great, ADLA is a great place, and ADLS is a great place for programmers to work with data. But typically programmers work with IT or for IT. And so if they're programmers, then there's less of a need to just give them visualization tools, right? They can write their U-SQL scripts themselves, and they can write their own, artifacts using R or Python themselves, right? But if they're users, I think it's a bad idea to put a visualization tool against a raw store like this. I think you're going to end up with aggregates spread out across all these artifacts, and you're going to have the old problem of, hey, how come my gross sales for that store says 72,000 a day on this report, and it says 86,000 a day on this report, right? As soon as you give users access to the raw data, you have that problem, and it erodes trust in the data, and it erodes trust in IT. So I would rather see IT, if they're going to put users on it, non-technical users on it, then they need to clean it and put it someplace that they approve. Does that answer your question? And then still have self-service, but put self-service on that store, not on this one.
Yeah, I think it does.
Okay.
So I will let you.
Okay, cool. Okay, so now I have Azure Data Lake Analytics account. And once I have it, I just click on it. This is, the same accounts that you saw me set up before, right? And what I can do with Azure Data Lake Analytics is I can specify, exactly which data source to use. So in this case, I click on data sources, and I have it configured to use the Azure Data Lake store that I was messing with earlier, right? Now, once I have that connected, it's just easier for me to create jobs that interact with it. So if you want to see all the jobs I've ever run on my account from time immemorial, you can see going all the way back to, February. This is me just playing with this account, right? Now, I've created a script here, and this is your first look at U-SQL. So this is what U-SQL looks like. What you'll notice, by the way, if I just duplicate this script. Hang on. Oh, that's what I wanted. Okay. What you'll notice, by the way, is I named the script version 2. And when writing your scripts and getting used to U-SQL, there's no inherent versioning. And so sometimes it's good to know, like, what version you're on, and is this my most recent version? So by adding that might be helpful. In addition, when you're first learning, what you want to do is keep your script very simple, and then add complexity to it as you go along, because you've got to run it to get things like compile errors and binding errors and syntax errors. You've got to run it. And so the smaller it is, you'll catch your syntax errors earlier, and you'll be able to identify where that syntax error is easier. So what I did in this script is really simple. I just went to my original file in baseball stats, baseball.csv. Remember, this is ADLS over here, and this is, let me go back. So this is my ADLS account. This is Data Explorer. Come on up. Okay, this is baseball stats here, and this is that original CSV. Okay, so what I did was I went to that baseball.csv, and I'm putting a schema over top of it. This is called schema on read, and it's a very powerful data tool that allows us to define the schema as we use the data, not as we create the data. So what I'm saying is, hey, there's a bunch of columns in this data, and those columns have data type. They have int data type and string data type. And then I say, please use an extractor to extract CSV off of this CSV file. And please skip the first row. Why am I skipping the first row? Because that's where my headers are. Okay. Now, look at these data types. What does that tell you? Int, string, what does that tell you? that tells you that we're using, are those SQL data types? No, that would be varchar, right? No, these are C# data types. And so even though this extract, looks similar, like from, and you'll see more SQL-like syntax in a little bit, there's a mixture here of C# and SQL going on. In addition, because of this, C# is case sensitive and SQL, Transact SQL, is not case sensitive. So the U-SQL for ADLA introduces case sensitivity. So it's important to know that. So that means this from and this using need to be uppercase. So get used to your shift key, because if you make them lowercase, it won't run. And so what I'm doing is I put a schema over this baseball CSV, and then I just output it, and I output it to my output folder to test.csv, and I just submit it. Now, while that's submitting, one thing I forgot to show you is that's my AU slider bar. And right now I only want it to cost like 3 cents. Before I ran it, I could have piped this all the way up to 8,000 if I wanted and spent a lot of money, but I just kept it at 1 because I really only want this to cost 3 cents. And what you could watch this do is it's doing very similar to what the SQL Server Optimizer does, where it's preparing the data, right? And then it's determining how to run it. And then it's giving me my output. I can just keep hitting refresh here. Uh-oh. Let's go back. There it is. And you can kind of watch, does this remind you of like query plans in SQL? Kind of similar, doesn't it? And as it goes, though, you can watch it go. And now it decided to use one vertex. This vertex is it telling you what parallelism it thinks it should have. So even though I specified only one AU, if I saw 20 vertexes here, that would be ADLA telling me, hey, this thing could really benefit from a higher degree of parallelism than it has right now. So now, once it runs, you can see my input was baseball.csv. My output was that test.csv, and if I click on it, I can just see my output right here. So that's my exact file. I didn't really modify that file. I just wanted to show you the basics of inputting data and then outputting data. If we go back to my script real quick, one other thing I wanted to point out was that, let's see, let's actually look at that script real quick, is I'm using variables here, so that at baseball stats is the variable that I'm using to hold that file with the schema, and then I output the variable to get it back out to test.csv. So you use variables in the batch processing to hold your place as you're working with the data. Okay, so that's a very easy script. Let's make a more difficult script. So I have another script here that I call highest average by team. And let's duplicate that script. Now, what I'm doing here, and again, zoom in because I know the text is really small. Actually, you know what? I'm going to switch. So I want you to know that I could run this easily here. Well, no, let's keep it here. We'll keep it here, sorry. Okay, so once again, there's my schema, right? Now, from the same file as before, right? Skip that first row, just like before. And then I'm saying, give me the highest home runs per team. So this select is a little bit more complicated. I'm saying, give me the team name and tell me the max home runs for that team. And of course, if I do that kind of aggregation, I need a group by clause. So those of you with SQL experience are probably pretty comfortable with that statement. And then I save that as highest home runs. And then because I want to know the player that hit those highest home runs, I take my original result, right, from baseball stats, and I take highest home runs and I join them to one another. I just say, hey, go get the team and go get the entry for the highest home runs and the team in order for me to get the detail of the player name coming back. And I save that as that result, and then I save that result as highest home runs.csv. So now I submit that job, and it runs. I can refresh this so we don't have to wait. It only takes a minute though. It doesn't take that long.
And Ike, while this is running, one of the questions we have here is, can you talk about how one handles the cost of performing development and testing in this environment?
I couldn't hear you because you kind of faded out a little bit. Could you repeat that?
Sure. Could you talk about how one handles the cost of performing development and testing in this environment?
Well, usually what you do is you just run it on lower nodes, because when people do big data projects, they have a budget, and so that budget, you need to understand that big data means big money. No matter how much people sell you on cheap, there's expense. And so in development and test, we just run on lower nodes. And then in production, when we need to run something every night to do some aggregation or some piping or whatever, then we can ratchet up the parallelism and pay more money. That's one thing. Another thing would be I would use source control. So right here in this interface, we're not using source control, but I'm going to show you a method where we can use source control. It'll be much better. Okay, so once this job, then why source control is important is because when something's working, you're going to want to be able to do the regular things like diff it and revert back if you have to, and understand your changes and migrations. Okay, so now I've got a new output file called highesthomeruns.csv, and if I click on that, you can see by team and the name of the highest home run. So, Jason lives in Minnesota, and the batter he probably might know is Brian Dozier, and he had 42 home runs. That's not shabby. He probably leads the league in home runs. So that's outstanding. My favorite team is the San Diego Padres, and their home run leader last year was Will Myers. He's a guy I just saw play this week. He beat the Cubs, who won the World Series last year, but we won the series with them last week. It was great. Apologize to any Cubs fans. My wife is from Chicago, so she and I went to the game, and I had a great time. It was wonderful. All right, so Will Myers is a great player, and we're really excited to have him, and he hit 28 home runs last year. So, but the thing I don't like is, unless I told you this was the San Diego Padres, you'd have no way of knowing it. So I want to show you something else that we can do with ADLA. This is the exact same script, but I moved it. I'm no longer in Azure Portal. I'm now in, where am I? I'm in Visual Studio. And I have tools for Azure Data Lake Analytics in Visual Studio. And what I do in Server Explorer is I connect to my Azure account. And once I connect to my Azure account, on my drop-down, I have ADLA Ike that I can use. And now it's the exact same script, but what do I have here? There's U-SQL, and boop, oh, that's a code behind file. And in my code behind file, I say, get the best team. And if you see as an input parameter, SDP, please replace that as the great San Diego Padres. And then if they're not the San Diego Padres, then just give them a blanket, give them the regular output, just return their input. So I can use that in my code. This is the same script you saw before, but look at this line of code where I say, take the team and pipe it into that C# and get a result back. And so now the same thing I did before, I can just submit it. But if I go to advanced, just like I can do in the portal, I can specify my degree of parallelism if I need to. Now I'm going to keep it at 1 because I want it to be cheap. And then I go ahead and click submit, and I see something that's comfortable. This is the same job processor that we see in the portal that they've moved over to Visual Studio. Well, guess what? There are a lot of tools for Data Lake. If you like Visual Studio Code, there is an SDK for Visual Studio Code. There's tooling for Visual Studio Code. You can write in the portal. You can write in Visual Studio. There's maybe even some more tooling coming out that makes it easier. Anyway, there are a lot of things changing to make this more accessible and easier for you. And now that you see it in Visual Studio, you can see where maybe I'd want this in source control like TFS or Git, and I can keep track of my versioning and my changes and things like that. This is where you should be doing development. So this continues to run, and then it says, oh, I'm finished, or come on, almost finished. And now when it's finished, I can click on my data tab and I can see my output, and I can click on it, and you can see that instead of SDP, or you see the great San Diego Padres, Will Myers, 28 home runs. And that's it, you guys. That gave you a basics. There's a lot more to Azure Data Analytics and Azure Data Lake Store. I'm teaching a Pluralsight course on the topic that'll be released shortly. And oh, you know what? I've got some other slides, but I don't think that they're super relevant. We're kind of out of time. But what I can do is, let me go back to my question slide. And you can see my name if you need to email me or tweet or go see my Pluralsight course or buy our book. Zoiner, Tejada, Michele, Bustamante, and I wrote that book together. And the old one, you don't want to buy the old one because it's 2 years old and it's way outdated, but the new one's coming out if you need it. Thanks so much for sticking around, guys, and let me know if you have any questions.
All right. Thank you very much, Ike. And at the moment, we seem to have gone through all of the questions that we had in the queue.
Oh, all right. Well, I hope everybody enjoyed it.
Yeah, we had quite a few people that came out today, and pretty much everyone stayed until the end. So thank you very much, Ike, and hope to have you back here to speak to the virtual group again sometime. And to everyone else, thanks for stopping in today. And this video will be going up to the Cloud VC or virtual group YouTube channel. So you can look for it there if you missed any portion of it.
Thanks, guys.
Yep, thanks.